In this week for Robot Studio, we will be talking about how to define a new tool so when you rotate around a point, your tip stays right where you want it instead of you having to reposition it every time. Alright, so as you can see here, normally we'd be rocking this magical point up here in space. Alright, that is where tool 0 is on the robot before you give it any tool data. Now ideally you would create a tool in the simulation and you would be able to tell it the exact information about where this point is, which we do actually have. So if I move this up into magical space, there we can go. You can see there is actually tool data specific for that point, right? The center of that. But we have never loaded it actually onto the robot controller. What we're going to do today is we're actually going to attempt to define that point on the robot end effector using a tool built onto the teach pendant. Now, the first thing that you will need if you're doing this in the simulation is a point to reference. If you're doing this in the real world, you'll still need that point to reference. However, in the real world, I normally put a pen or something sticking up, or a chopstick or something again that has a very fine point to it. In this case, since we are in the simulation, we're going to be dealing with that magical point on the end of that other end effector that I just put in. So that magical point where that blue, green, and red line come in, that's going to be our point that we're going to try to get the very tippy top of this to be at every time we save a new point. Now, to do this, we will first need to have Robot Studio opened, obviously. You will need to be in manual mode. Make sure you have enabled the device. So it should say released device here if you have already done that. You will also need to open up your teach pendant. Now let's go ahead and reset this back to my home position. So we're starting up nice there. We're going to have to go ahead and put it back in manual mode, as I said, and make sure I've enabled that device. Now as you can see here, we are, I do have my tool 1 that I just created, but we're going to go ahead and make another tool. We're going to actually give it a real name this time. So what I need you to do is on the teach pendant itself, go ahead, click the menu, top left corner, and go to Program Data. Now, we are going to be creating tool data, so we're going to have to go to the tool data screen and go ahead and hit Show Data. And here we can see the different tools that we have. Now, the first thing we need to do, obviously, is create a new tool. So we're going to go ahead and create one. I'm going to call it Vacuum. Now, the scope, you do have task, you do have global, local, whatever you want to choose for our purposes today. I'm just going to leave mine at task. That is where we started. Now, in an ideal world, you'd be able to say initial value, and you'd be able to type in your X, your Y, and your Z coordinates, as well as your Q values, and you'd be good to go. However, most likely, you don't know that data if you're going this route, so we're going to just, oh, doesn't like us, go ahead and hit cancel, and then go ahead and hit OK. Vacuum tool. Alright, make sure you pick a name that it's happy with. Now, we need to define this. So make sure you have vacuum tool selected. Go ahead and do edit and define. Now the method we are going to be using today is the TCP method. And TCP is your tool center point. So that is what we are going to be training it. There are TCP and Z and TCP and Z and X. We're just going to go with the default option. And we're going to go ahead and be a little lazy today, and we're going to drop it down to 3. In theory, the more points that you use to train this, the better off it will be because it'll be able to average out your errors a bit more. However, 3 is the minimum number that you need to use. And what we're going to do now is you are going to manually move the tip of this to basically be at the tip of that. Now, starting off where I did, ooh, there we go. Alright, let me go ahead and view center there. Alright, so we can kind of cheat right off the bat. We are aligned perfectly in the 1 axis, which is nice. Alright, so we can go ahead to our teach pendant. We can go to the jogging screen, make sure you're in a motion mode that you are happy with. And we can go ahead and in theory just move this straight down and in until we get this as close as possible to that other tip. Now, when I did this earlier, it got mad because we got this joint a little bit too close, what they call singularity. Everything is too straight and aligned and it causes problems. So I'm going to cheat that a little bit here. We're going to go into joint mode. That is joint 5 that I want to change. And we're just going to bend that down real good. And I want to do it that way instead of in reorient mode because I didn't want to accidentally go left or right or anything. So now we can go back to our our linear jog, and we can work on getting that perfectly lined up. Too much. And yeah, this is a bit of a back and forth and a back and forth and a back and forth, and it gets very annoying, but that's just the way the game goes. In the real world, working with actual robots, this is a bit nicer. And up. Now, as you can see, I am pretty stinking close. I don't know how close I am, but I would guess I'm within a few millimeters. So I'm going to call that one good enough. And on the teach pendant, you're going to go back to program data, point 1, and then say modify position. Now we need to do this 2 more times, and ideally you want these like 120 degrees out of phase from different angles. So while our first one is perfectly vertical, if you want to do your second one like perfectly horizontal, or even coming like angling up towards that point, whatever way you want to do it. The farther apart these are, the better off we're going to be. So how I like to normally do this is I will come down back into my jogging, go into reorient mode, which remember we're reorienting around the end of the actual robot right now. And I like to just kind of give that some twisting action. Oh, I'm cheating. Alright, that's alright. I'm using my tool 1 right now. So, but if you were in, which you guys have, tool 0, so when you do your reorient, it's going to, come on, there we go. It's reorienting around this magical point up here, so you can see that's how it normally would happen, is your stuff would become off-center. So now you have to get that all lined up again. So we're at a much different angle. I like to look at the robot straight on, if I can figure out how to do this. There we go. Alright, so nice straight on, and then I'll bring this back up. Make sure you go back to XYZ mode, and then I'll normally try to get 2 of my axes lined up as close as I can. Ooh, too much. Feel free to go to slow mode if you want, or medium speed, or whatever. Alright, now that I've gotten that one, I'll just rotate straight to the other direction. So now in theory I have 2 of my 3 axes. Make sure you click the right axis when you're changing. And we need to go down a little bit more. And again, because we're in a simulation, we can crash the robot in the actual world. Like, if those are touching, we're actually doing our job, per se. And again, you can see we are very stinking close. Alright, we're going to call that point good for option 2. So we can then go back to program data, point 2, do our modify position, and do it again. So we need to jog our robot to some other crazy location. Alright, so we can just go to reorient mode. Maybe be able to see my robot at the same time. And we'll take this all the way around. That looks good. Alright. So that looks like a good option. Everything's kind of screwy. And again, I will look straight down on the robot. Go back to linear mode. Jog it sideways. Oh, jog it down. Again, try to get those 2 axes lined up as perfectly as I can by looking straight on, which, oh man, I'm feeling pretty good about both of those at this point. Alright, and then again, I will use center there, rotate it. So in theory, all I have is one axis left to fix, and I'll slide it back. Now, as you can see from me doing this, I was way off in the Z, and I mean way off in the terms of being super zoomed in. Alright, we're not as close as I want to be yet, so we can go ahead, bring that back a bit more, bring that down. Alright, and again, just keep kind of getting closer and closer. You can see I'd be hitting if I was in the real world right now. Oop, wrong way. And again, that looks really good, so we can go ahead and call that point 3. We've got our 3 points now. Again, the more you do, the better off you are, but 3 will work. We can go ahead and hit OK, and it's going to take a second to process. And you can see how it says our max error, our minimum error, our mean error, and it tells us all that. So our max error was 1 millimeter off. I'm calling that perfect. All right. You don't want to see that number too big, otherwise it's not going to rotate nicely around that. Now, if we scroll down, we can see it tells us our X and our Z, how far off we were in those axes, and we can go ahead and say OK. Now, we still do need to go into this and change our value. All right. Notice it gives us so our X, Y, and Z, how far we were off, and this one's perfectly fine. However, we still need to make sure that we tell it what the mass of this end effector is. Now, anything over 0 and it's happy. Ideally, you would put what the actual end effector weighs. Obviously, in our simulation, we have no clue how much that weighs, so we're just going to give it a value of 1 and go ahead and hit OK for that, and then OK. So now, if you go to your jogging screen, and we go to reorient mode, and we go to our tool, we go to our vacuum tool, we can go ahead and hit OK, and in theory, if we reorient this, you should see those points basically touch the entire time. So no matter where I reorient this, and the really crazy thing that I like watching is watch the robot as I do this. It's moving in and out and rotating, and it's not a simple move anymore. It's not a simple, oh, we just rotate this one axis. No, it's everything is changing as we reorient things. But that magical point in space is, in theory, not changing. All right. Again, this is not a perfect option, but it is pretty stinking close when it comes to getting a tool up and running. And the wonderful question always comes down to is, what type of accuracy do you need for that? If we go back to our simulation, not our simulation, our little trainer we have in the robotics lab where it physically is rotating that disk in space over a sensor, and we need to make sure that it's finding that hole and whatnot, maybe that becomes a bit more important. Where if all you're trying to do is just get your suction cup so you know roughly where the center of that suction cup is when you're trying to pick up your blocks, then this is accurate enough for our purposes. So one of those things to think about, but overall, that is how you teach an ABB robot about the tooling that it has.